5.4, the binomial theorem. So reviewing what a binomial is, this is a polynomial with two terms, okay, and it's in the form a plus b. So some term plus or minus some term. Okay, so what we're going to be taking a look at right now is expanding a plus b to some exponent n. What happens is it becomes very laborious as n increases. So instead of doing this by hand, we use the binomial expansion to make expanding easier. Okay, so as an aside, we see in grade 10, say we had like x plus 1 squared. Well, we know that we're going to do x plus 1 times x plus 1, and we're going to have to expand, and we're going to end up with 3 terms. Now, imagine this was x plus 1 to the exponent 3. Well, then we're going to have to expand this 3 times. X plus 1, x plus 1, x plus 1. So you're going to do the original expansion, then you're going to again expand it by x plus 1. So you could only imagine that as n increases, say this is 10, and we're multiplying x plus 1 by itself 10 times, it's going to be very, very tedious to do this, and it's going to take a long time. So instead, we use the binomial theorem, which we use, and we can just use patterning for each one of the terms. So I'm going to go over this. So if we had a plus b to the exponent n, okay, what we're going to see is we're going to see n choose 0 as the coefficient. Then we're going to see n choose 1 as the second coefficient, then n choose 2, all the way to n. Sorry, choose n. Okay, and where we can get these choose numbers from is we can either put them in our calculator, or as a reminder, these are going to be the inputs of Pascal's triangle. Okay, for the scope of the binomial theorem in data management, we're going to use the choose function. Now, here's where we pattern. So we're going to start with a to the n, and then this is going to be a to the n, sorry, this is going to be minus 1, a to the n minus 2, this is a typo, please change it, a to the n minus 3, a to the n minus 4, a to the n minus, all the way to n minus n. So essentially, in this term here, it's going to be a to the n minus n, which is just a to the 0, which is just 1. So that just goes away. Okay, and that's why in this last term, there's no a part of the variable. Now, patterning with the b's. So this second term, we're going to take that, and we're going to start with b to the 0. Which obviously cancels to 1, so there's no b variable in the first term. Then it's going to be b to the 1, b squared, b cubed, b to the 4, b to the 5, b to the 6, all the way up to b to the n. So as a short form, a plus b to the n is the Riemann sum from r equals 0, so from like the first term, all the way up to term n choose r, a to the n minus r, b to the r. This is like the general form for the equation. Okay, so note these patterns, and these are what we're going to be using in order to expand. So the degree of each term in the binomial expansion of a plus b to the n is n. And I'll show you that hands-on. But if our original exponent is n, then these two exponents are going to add to n on every single term. Okay, exponents on the first term are decreasing from n to 0, and exponents on the second term are increasing from 0 to n. And then the coefficients are the nth row in Pascal's triangle, and we calculate this by using NCR. So for example 1, applying the binomial theorem, expand each of the following using binomial expansion and Pascal's triangle. Okay, so I can leave this up here to show the expanding, but I'm going to I'm going to just show you guys how to pattern. So this exponent is going to be our n value, so n equals 6. Okay, that means I'm going to tell you we're going to have 7 terms. So to pattern our choose functions, we're going to go 6, choose 0, 6, choose 1, 6, choose 2, 6, choose 3, 6, choose 4, 6, choose 5, and 6, choose 6. Okay, our choose function is patterned for the entire expression. Now, let's take our first term and let's pattern that. You know what? Let me do this in a different color just so that we can follow along. Okay, we're going to do that with blue. So we're going to start with a to the n, which is 6. So a to the 6, a to the 5, a to the 4, a to the 3, a to the 2, a to the 1, a to the 0, which cancels out. Then we're going to pattern the b. So we start with b to the 0, which cancels, b to the 1, b to the 2, b to the 3, b to the 4, b to the 5, b to the 6. So let's go ahead and simplify. So in regards to the choose functions, we can either put this into our calculators or we could reference Pascal's triangle. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 0, 1, 2, 3, 4, 5, one more, 1, 6, 2, 15, 20, 15, 6, 1. Okay, this is going to be the 6th row in Pascal's triangle. So this is row 6. As a reminder, we start at row 0. So 0, 1, 2, 3, 4, 5, 6. Then also as a reminder, row 6 actually has 7 terms. So whatever our n is, our number of terms is going to be n plus 1. Okay, so these simplify to 1, 6, 15, 20, 15, 6, 1. Okay, so this entire line is going to be the coefficients. Now, and by the way, these might change if we had coefficients of a or b. But for this question, it's very simple. Okay, so let's go ahead and simplify a to the 6, b to the 0. We just get a to the 6. Then a to the 5, b to the 1, we just write that as it is. A to the 5b. Okay, we just write a to the 4b squared as it is. So none of these can actually simplify, so we're actually done our question. So just write out the variable terms, and this is how we would expand a plus b to the exponent 6. So let's expand 2x minus 1 to the exponent 4. Okay, so let's do the choose functions first. So we're going to start with 4 choose 0, give it some space, 4 choose 1, give it some space, 4 choose 2, 4 choose 3, and 4 choose 4. That's how you pattern for the coefficient. Now, let's pattern for the first term. So we have 2x to the exponent 4. Then we have 2x to the exponent 3. You notice I'm bracketing the 2x. 2x to the exponent 2. 2x to the exponent 1. And then 2x to the exponent 0. And again, this goes away and cancels to a 1. So multiplying to 1, we're just going to disregard that. Okay. Now, negative 1, let's pattern. Negative 1 to the 0, again, disregard. Negative 1 to the 1. Negative 1 to the 2. Negative 1 to the 3. And negative 1 to the 4. Now, let's simplify this. So we can put 4 choose 0 into our calculators, or we can choose row 4 in Pascal's triangle. So you should be able to go to the bottom of your paper and pattern Pascal's triangle here. Okay, 0, 1, 2, 3, 4. This is row 4. It has 5 terms. Okay, so we're going to get coefficient 1. I'm going to do this in order, so I'm not going to sub these in yet. So I'm going to get coefficient 1 times, so we have 2x to the exponent 4. As a reminder, 2x to the 4 is not 2x to the 4. So when we're dealing with this, we have to remember what we're essentially doing is putting in 2x into brackets 4 times to multiply them by each other. So what we're going to essentially get is 2 times 2 times 2 times 2. 2 and 2 is 4, 4 plus 8, 18 is 16, x to the 4. So this is now times 16, x to the 4. You notice how this is not by just the coefficient by default. The 1 is then going to be multiplied by 16, x to the 4 in the next line. Okay, and we're going to see that as a pattern here. Okay, next one. We have coefficient 4 times 2 cubed is 8, and then x cubed. And then negative 1 to the 1 is negative 1. All this is actually doing is going to negate this term so that this term turns into a negative. Okay, 4 choose 2 is going to be 6 times 2 squared is 4, x squared is x squared. Now, negative 1 squared cancels to a positive 1. I'm going to leave that out. Okay, 4 choose 3 is going to be 4 times 2x to the exponent 1 is just 2x. And then negative 1 cubed is going to leave us with negative 1. Okay, 4 choose 4 is going to be 1. This canceled out already. And negative 1 to the exponent 4 cancels to a positive 1. So let's just leave that. Put equal signs. So in the next line, all we're going to do is collect any x's with exponent laws or multiply the numbers. So 1 times 16x to the 4 is 16x to the 4. Now this term is going to be negative. 4 times 8 is 32, x cubed. Okay, this term is going to be positive. We get 24x squared. This term is going to be negative. We're going to get negative 8x, and then bring that down, plus 1. So, 2 highlights. First, cannot collect, there's no like terms, so we're done. And the second thing is, if you notice, the pattern is positive, negative, positive, negative, positive. So alternating positive and negative signs. Okay, so again, if there is a negative in the original, it's going to alternate positive, negative signs. Okay, so now we have 3x minus 2y to the exponent 5. So let's pattern 5, choose 0, leave lots of space because we're going to have 2 terms, one being 3x and one being negative 2y, right? It's going to take up a lot of space. Okay, so 5, choose 1, 5, choose 2, 5, choose 3, 5, choose 4, 5, choose 5. Okay, so now let's pattern. 3x to the 5, 3x to the 4, 3x to the 3, 3x to the 2, 3x to the 1, and I'm actually going to start leaving it off. So 3x to the 0, we don't have to include that at all. If you did, that's okay. You can just include it and then cross it out. Okay. Now negative 2y, get rid of that. Negative 2y to the 1, negative 2y to the 2, negative 2y to the 3, negative 2y to the 4, and negative 2y to the 5. So a couple things that we already know. We're going to use row 5 of Pascal's triangle. So let's do that. 1, 4, 6, 4, 1, 1, 5, 10, 5, 10, 5, 1, 1, 2, 3. Row 0, 1, 2, 3, 4, 5. This is row 5. 1, 5, 10, 10, 5, 1. So 5 choose 0 is 1. Now 3x to the 5. We have to, I'm going to do this in 2 steps so that it's very, very clear. What we're actually doing is we're doing 3 to the exponent 5, and then we're doing x to the exponent 5. Okay, so that's what that's going to be. So if we do 3 to the exponent 5, we get times 243 x to the 5. Okay, next one. 5 choose 1 is 5. Now, 3 to the exponent 4, I'm going to put that in my calculator. We get 81. So this is 81x to the 4. Now, negative 2y to the 1, we can just put times negative 2y. Okay, we're going to come back and multiply all of these. 5 choose 1 is going to be 10. 3 to the exponent 3 is 27. Yep. So this is going to be 27x cubed. Then, negative 2 times negative 2 is positive 4. So this is going to be 4y squared. Plus 10. 3 squared is 9, so we get 9x squared. Negative 2 to the exponent 3 is going to be times negative 8 y to the 3. 2 and 2 is 4, 4 is 8. Okay. 5 choose 4 is 5. And then 3x to the 1 is going to remain as 3x. Then negative 2 to the exponent 4 is going to be positive 16 y to the 4. And then 5 choose 5 is 1. And then this is going to be negative 2 to the exponent 5. We're going to get negative 32. And that's going to be y to the exponent 5. Okay, so now let's simplify. 1 times 243 is 243. And we're left with x to the 5. So for this one, I'm going to multiply 5 times 81 times negative 2. And I get, oh, I don't even get positive. That's right, I get negative because it's going to be alternating. So negative 810 x to the 4y. Okay, next one's going to be plus 10 times 27 times 4. So I get 1080. Then I get x to the 3y squared. Okay, the next one's going to be minus. So 10 times 9 times negative 8 is going to be negative 720 x squared y cubed. X squared y cubed. Okay. The next one's going to be positive. So we have 5 times 3 times 16. And we're going to get 240 x y to the exponent 4. And then this one, because negative 32 y to the 5 is just multiplied by 1, this is just negative 32 y to the 5. Okay? A couple things about this. So our n equals 5. Therefore, there are 6 terms. Okay, the term numbers go in order. This is term 1, this is term 2, this is term 3, this is term 4, this is term 5, and this is term 6. Okay, there are 6 terms here. Okay, one of the terms is negative, so it's alternating negatives. So positive, negative, positive, negative. Okay, and there are no like terms, so we can't add any of these up. Now we have x plus 2 over x squared to the exponent 4. Okay, so let's go ahead and pattern. So we're going to have 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. Okay, let's pattern the x's. X to the 4, x to the 3, x to the 2, x to the 1, x to the 0, I'm not including. Okay, and now let's pattern this fraction. 2 over x squared to the 0, again, not including. 2 over x squared to the 1. 2 over x squared to the 2. 2 over x squared to the 3. And 2 over x squared to the 4. Okay, so again, you can use your calculator or you can use Pascal's triangle. Row 0, 1, 2, 3, and then 4 is this. Okay, 1, 4, 6, 4, 1. So this is going to be 1x to the 4. And that's fine. That's simplified. Now we're going to go 4. So 4 choose 1 is 4. I'm going to leave x cubed as it is. That's what's really nice about this is x cubed is just going to be x cubed. Now this is going to be multiplied by 2 and then divided by x squared. Okay, and then leave that. Now we have 6, so 4 choose 2 is 6. X squared, leave that. Now, how we actually expand like 2 over x squared squared is we multiply this by itself 2 times. So 2 over x squared times 2 over x squared. So what we're actually going to get is 4 over x to the exponent 4. Okay, the other way that you can look at that is we can consider this, if we have 2 over x squared, we can consider this square the numerator and square the denominator. So square the numerator, 2 squared is 4, square the denominator, x to the 4. Okay, so it's either or. 4 choose 3 is going to be 4, x to the 1. Then let's do 2 cubed, so 2 and 2 is 4, 4 and 4 is 8. And then x squared to the 3. So just as a reminder, if we had x squared raised to the exponent 3, the exponent laws is multiply. So this is x to the 2 times 3. So this is x to the 6. Okay, plus coefficient is going to be 1. 2 to the 4 is going to be 16. X squared all to the exponent 4 is going to be x to the 8. This is just asides. Okay, let's simplify this. 1x to the 4, I'm just going to write this as x to the 4. Okay, now plus, let's do the numbers. 4 times 2 is 8. Now, if we're doing x cubed divided by x squared, x cubed over x squared, as a reminder, exponent laws, we're going to do numerator minus denominator, like the exponents. So this is going to be, oops, that's a 2. This is going to be x. Okay, next one, let's do the numbers. 6 times 4 is 24. X squared over x to the 4 is going to leave us with x squared in the denominator. If we actually take a look at that, and I'm trying to give myself some room, x squared over x to the 4, if you look at this as in expanded form, it would be x times x in the numerator, and then x times x times x times x in the denominator. So what will actually happen is 2 of these are going to cancel out, and then leaving a 1 in the numerator. So 1 over x squared. Okay, 8 times 4 is 32. We have x to the 1 over x to the 6, so it's going to be x to the 5 in the denominator. And then 1 times 16 is just 16 over x to the exponent 8. None of these are like terms, so we can leave them. Okay, the only other way that you may want to write this final answer is x to the 4 plus 8x plus 24, and instead of writing x squared in the denominator, we can write x to the negative 2. Instead of writing x to the 5 in the denominator, we can write x to the negative 5, and then x to the negative 8. So that would turn into 24x to the negative 2, 32x to the negative 5, and 16x to the negative 8. These are equivalent. You do not have to do this last step. You can leave it as fractions.